Greetings, everyone. This is Eric Andelin with SimActive. I am your Senior Workflow Specialist, and you're joining us for our webinar, How to Use Photogrammetry to Calibrate Sensors. And I'd like to welcome my guest, Ken Scruggs. Ken, say hi.
Hello, everyone. Ken Scruggs. I'm founder and owner and president of Midwest Aerial Photography
The man who does
based
it
in
all.
Ohio.
The man who does it all.
Yeah, and take out the trash occasionally.
Right, right. So give me a little bit of detail or some information on how you got involved in aerial photography, mapping, all of that.
Well, actually, it was a combination of circumstances and events throughout my earlier life. I went to Miami University of Ohio and their engineering program. And while I was going to school there, I picked up photography as a hobby, but it was strictly a hobby, had nothing to do with anything else. So after school, I went to work for an engineering firm in Columbus, Ohio. And in that position, I got exposed to survey crews, was out on survey the field quite a bit. But it just so happened that this firm had a small mapping division. And this was long ago enough that most everything was photographic based. And that's where my interest was. That's where my passion was. So I switched from engineering to the photogrammetry section, and I worked for them for another 10 years. Then at that time, I kind of got ambitious and thought I could do a better job and do things better. So I put what little money I had where my big mouth was, and now I'm in business. That's the easy part. The hard part was I proceeded to starve for the next 5 years and really thought how long and hard and contemplated did I make the right decision. And the alternative was not good, and I just chose to stick with it. And here we are. And that was 32 years ago.
Yeah.
So it's been a long, interesting process. I can say that I haven't been bored in 30 years for sure.
Yeah. Well, I tell people all the time in these webinars that, I came from that same background. My dad started aerial photography in, I think, 1980, and he did kind of the similar thing. He worked for an engineering company. He actually worked for Fugro, and Fugro had a mapping department at the time in Los Angeles. And he was dealing with the local aerial photographer that they were subcontracting work out to all the time. That gentleman wanted to get out of the business, so my dad decided he was going to jump in and purchase his company. Starve, as you said, for a few years. Fortunately, he had a military retirement that he could use to help out, but it sounds like the path is very similar.
Yeah, I think most of us in this industry, we all started out as technicians,
Yeah,
and then made a transition, hopefully successfully, from a technician to a business owner with an owner mindset. And sadly, some people don't make that transition successfully, and they're
yeah.
not with us today, as a business anyway. So it's a completely different mindset, and it's not the easiest thing in the world for sure for a technician.
Well, and it's funny because you and I are both MAPS members, and we see that even today. We've got young MAPS members who, might only have a plane. They don't even have a camera yet, and they're still interested in getting involved in the aerial photography and the lidar side of things. And it's still certainly a very viable business if you've got a good business plan. You know what you're doing. I'll put up a slide here, but what I wanted to bring up was what we would be talking about. And we're going to have a discussion in general about things, but some of the things that we want to cover so that people can follow along in the webinar, we're going to talk a little bit about aerial mapping in general, choosing the right sensor for what you're doing, collecting optimal data for calibration, because these sensors do need to be calibrated, performing calibrations, and then actually monitoring your cameras over time, because they do need to be constantly monitored to make sure that you're getting the optimal results to provide the best mapping that you can. Just in general, on the aerial mapping side, you started out with one plane, I assume, in a camera.
Started out with a Cessna 206 and a an RC8 film camera.
Okay. Wow. RC8s. That's way back there. I think.
Yeah, yeah. Well, the good thing about an RC8, you could actually go to a hardware store and buy parts and repair it.
Yeah. I mean, I started in the back of a plane with an RC10, so I'm definitely familiar with the mechanical side of cameras. That's for sure. So from
Yeah.
there, you know, you worked with RC8s. I probably a 20 and a 30 at some point. You know, what was the intent? So you were in Ohio. How did you grow the business?
Uh, in those starving years, I realized that there are a lot of people that could do a lot of things, and for some strange reason, they were doing it cheaper than I could, and and I was the low overhead dealer. I didn't have an office, I didn't have a staff,
Yep.
I didn't have all these base expenses. So I realized pretty early I had to figure out how to do things that everybody else was not willing to do or were unable to do.
Right.
And part of that was simply make my backyard, a lot bigger than it was.
Mm-hmm.
So over time, I was buying another airplane, then buy another camera system, and now I'm actually into, like the third generation of cameras, uh, with all the digital stuff that we're doing. So sadly, you spend so much time and effort and money to buy these things, and sadly, in a few years, they're big doorstops, and that's just the nature of the beast. In this industry, you got to get as much as you can as fast as you can because it's just going to be a point where it just has no viable use in the marketplace, and that's always a tough cookie to
Mm-hmm.
to work with on that. But over the years, I'm up to 10 aircraft now. We're spread across the United States from California to DC to Florida, in addition to headquarters in Ohio, with multiple camera systems. We have 5 digital large format systems, 2 optic LiDAR systems with co-mounted with phase 1 cameras. And we've worked with smaller format cameras. I've used Nikon D800s just for some testing,
Mm-hmm.
purposes. But typically, if you have the larger formats, you're not going to be using the smaller formats.
Yeah.
We reach a point where we have a big toolbox, and you just look at the job, and with your experience, you turn around, go to that toolbox, and you pull out the right tool that's most appropriate for that project. And it might be large format, it might be medium format, it might be LiDAR, it might be a combination of multiple of your tools to get the right end product.
Right. Absolutely. And I remind our viewers and listeners that, um, I'm going to spill the beans here a little bit, but Sim Active is going to have its 20th anniversary next year. So we've been around for quite a while, and we started in that large format world. And even though that's where we came from, I would say a lot of our business right now is in the medium format world with the phase 1 cameras, and we do drop down to the level of drones. But a part of the discussion I always have with people is, the amount of time it takes to process an image doesn't change whether it's a small format image or a large format image. The actual processing time is the same. So if you're flying something and you've got an option to do it in large format where it's going to take you 6 exposures versus 600 from a drone, you're way better off subcontracting that work to somebody who's got a large format aircraft, to get that work done if you're talking about doing things quickly. So like you said, it's your tool in the toolbox, and some people have small toolboxes, some people have really big toolboxes. And as that toolbox grows, you have to be savvy enough to know which is the right tool for the project that somebody's trying to accomplish. So you mentioned also that you have a couple LiDAR systems.
Correct. Yeah, we have the Optec Galaxy Prime systems, and we have 2 of them, and both are mounted with phase 1 camera systems. So some people have a preference of wanting large format and LiDAR. Some are okay with the phase one imagery. And I think that really just depends on the work, their internal workflows on
Yeah.
that. You know, since we are essentially a data supplier, you know, to the industry, uh, you know, we give them what they want.
Yeah.
You know, it just doesn't matter. You know, pricing is separate. Um, we like to feel that we are an augmentation to companies of all sizes. So our equipment is top of the line. We have enough of it, enough aircraft, enough staffing that we can partner with a much smaller firm. Maybe they're only a year, 2 years old. Maybe they just simply don't even want to have airplanes. But we can partner with them, and suddenly they can compete, you know, with anybody in the United States because we have all the right equipment, you know, for that.
Right. Right. Let's talk a little bit, and I mean we're kind of going down that road anyway, but about um, choosing that right sensor for a project. As you said, you guys are kind of a data supplier, so maybe it's more often that your customer dictates which camera system they may want, or which lidar system, or do you find yourselves educating the end user on what might be the best tool for the project?
We find ourselves educating. You
Mhm.
know, back when I got my first digital large format camera, I thought, okay, we're it. You know, here we are, ready to go. And so I went out and started talking to people. It's like, is that large format or is that medium format? You know, suddenly the questions were like, oh, they don't know. I need to help them along in integrating
Mhm.
the digital camera systems into their workflows. And it's never stopped. It continues, you know, to be that way because we do this every day. A lot of our customers don't do it every day.
Right.
So we're always in a matter of more of a conversation. It's not really a classroom, you know, setting. It's like, you know, well, what do you need? And we're asked, you know, what do we think? You know, what would be the best system? Sometimes the economics determine that. If it's just a small project, maybe a mile in length over a section of highway that might be, you know, several hundred miles away from where we're going to be with our aircraft, well, okay, a drone can do that.
Mhm.
You know, much more economical. We can't get our airplane there for the kind of budget that that kind of project will have. So every tool is going to have its place.
Yeah. Yeah. That's definitely true. And it's funny because the webinar we did prior to this, I did with Pat McConnell, and we were talking even for him at the time he was selling cameras when they switched to digital. And he said he spent a lot of time just educating the customer on the difference between, say, map scale and GSD, and going from film to digital cameras and pixels was a big challenge for a lot of people to understand.
That's exactly right. Because the film, especially like the 6-inch 9x9 film camera systems, were such a standard, literally for decades, and many people spent their whole life, you know, in that. And going into a digital was a whole new ball game. And what part of the problem was every digital camera was different,
Different, yeah.
had different number of pixels, different focal length, and this was something that was unusual and uncomfortable for a lot of people.
So, and you can correct me if I'm wrong, but I assume that's why, and I think I even said it in the last webinar, that's kind of why calibration disappeared, at least in the States via USGS, because the number of sensors that were coming in were no longer film cameras and 9x9. It was a different digital camera from a different manufacturer all the time, and they had honestly probably didn't have the skill set or the equipment to calibrate those cameras.
Well, yeah, that's right. That's right. And they got to be voluminous. The calibration lab at USGS in Reston, Virginia, it was just two guys,
Yeah.
and you know they could do 2 or 3 camera systems a week. It was, you know, that was their workflow. Now you start throwing in literally hundreds of different systems, and it would simply overwhelm them. They just simply weren't prepared for it. Plus, their everything was geared for the 9x9, film
Yep.
system.
Yep. And now, like you said, we've now moved to even to the medium formats, which are, for example, phase one is pretty much a metric camera. It's designed to withstand atmospheric conditions and things like that, but yet it still has to be calibrated. So let's talk a little bit about, a little bit more about calibration. And you mentioned that, back in the day, at least here in the States, it was two guys that were doing the calibrations. And I can remember the agony that anybody felt back then when they had to ship their camera out to Reston and they may not see it for 3 months while they're waiting for a calibration. And then, fingers crossed, they get a good calibration, because back in the day, most of the contracts out there required a certain quality or AWAR,
Right.
to do that type of work. And if it came back, and again, this is a human thing. If it came back with a lesser calibration, maybe just because that day it didn't happen to work out for that person doing the calibration, that you were in a world of hurt. So, maybe that's a good thing about, the way calibrations change now. It is more scientific, I guess, maybe. I don't know.
Well, I think we're in a different ball game on that. So one of the first things that always struck me wrong with some of the terminology. To me, a calibration was when you take something, you tweak it, and you make it fit. What they're really doing was validating and measuring the performance. They weren't changing anything. They weren't adjusting anything. And so you just had to, hope that the structural integrity of the interior of the camera system was good. Sometimes it would change a little bit and not. But the other thing that was happening, you never hear anybody talk about AWAR, which is average weighted area resolution.
Yep.
And I think that's mostly because in our age now, the lenses are designed by computers or computer aided design, and we have clear imagery or high resolution from the center of the image all the way out to the corners. That wasn't the case years ago.
Yeah.
So, and then what we're really doing now, we're doing an in situ calibration, or I want to really use the word validation, where you're testing the whole system in the environment in which it's going to be used. So, in the old days, with the film cameras, you send it into lab and say, "Oh no, you got to send this in, the Friday before so it can stabilize the temperatures and everything's right." And I'm like, "What are y'all talking about? This isn't the way we're using it in the real world." And you take off the ground, the temperature is 70 degrees. You go at the altitude, it might be 30 degrees.
Yes.
And there's a temperature difference from the top of the camera system to the bottom of the camera system. It's like, well, that's not the way that we're using it. And I always thought that was kind of an odd way to do it. But so today we're essentially, most of us have we call it a validation range. It's an area maybe 1 mile by 2 miles in size. Ours has about 40 control points, in it. And we're flying it at different altitudes, and we're testing it in the real world environment is what we're doing on that. So it's not in a lab.
Yeah.
And so then we run through, the process, and we're validating both the geometry of, the camera system itself, and also, working with coordinating the exterior orientation with the XYZ, positioning and the omega phi kappa exterior orientations.
So we've moved from lab calibration to field calibration. I agree with you in that nobody flies in a lab, nobody flies a project in a lab. So therefore, I don't know how valid that lab calibration necessarily was. But again, even in the drone world, we have a prior company I worked with, we have a validation field not too far from here, and it had 20 leveled through control points, so we know those control points are right on. Drones, of course, usually have off-the-shelf cameras. They're not, exactly stable. There's a lot of plastic in there. There's a lot of moving parts. Things move around. So when we would do a project, at least maybe every other week, or when we were out training or whatever, we would put them over the validation site, and they would do calibration that way, so consistently keep it up to date. You guys do similar to that. I would assume you've got it somewhere near one of the airfields that you operate out of. You can quickly hop up and grab that area, whether it's on your way out to a project or on your way back, and you can kind of use that to help validate things. So when we talk about that, you were talking about in these calibration fields, you fly at different altitudes. So explain a little bit about that and why you're doing that, as far as how you're validating your calibration.
Uh, we do, if we're doing a bore site,
Mhm.
which is we're really, tying everything down. We will do two different altitudes just to have a variety. So we're not in a narrow focus. And what that does too is it puts the whole, control field in different parts of the camera system of the
Gotcha.
imagery. It's Can you do it with one altitude? Yeah, sure. We're doing it with two just as a extra little effort
Mhm.
on that. Uh, since we're talking about that, we do this on a regular basis because we got multiple flight crews, and you just don't know when that big size 10-foot, in that airplane hit something the wrong way, maybe just jostle the
Mhm.
IMU or something. Uh, if it's not just exactly right, it's going to show up in your end results.
Mhm.
It's just not going to be there, especially getting into direct georeferencing. And another comment you mentioned about the type of camera sensors on some of the drones. Well, you get into with our large format, we was always used to doing something for engineering design. It had to be right on the money
Yep.
on the positioning. Well, a lot of the stuff, we loosely call it GIS quality, but it's like it's good enough for what we're trying to do.
Yep.
We're just trying to put things in perspective. We're not going to be building anything on it. We just want to know what's there.
Mhm.
So again, that's another driver for multiple different tools in that toolbox. You don't need to run $1 million camera system, over a project where you just need to put some kind of relationship on where things are to one another.
Mhm. So you brought up a term that I want to just get clarification on. So is there a difference between a calibration field and a bore site?
It can be the same field.
Mhm.
The differences are, uh, again, we're using the word calibration. I really like to use the word validation.
Okay.
And what we're
Yep.
doing is we're validating the geometric integrity of the camera system.
Okay.
You fly the site, you've got control points out the wazoo. You use these, some as control points, some as checkpoints, and you're doing AT, and then you do your checkpoints. And yes, this thing is geometrically a valid system. When you get into a bore site, now we're adding in the GPS, and I'm using GPS as a general term
Sure.
for any global navigation system
Yep.
on that. And the IMU, now we're getting into exterior orientations. The geometry is only interior orientations, and
Mm-hmm.
the IMU and GPS are exterior orientations. And so of course, you got the same data, and now you have an AT. Now you can compare that to what the raw data is from the IMU and the GPS, and you can make some adjustments and have offsets,
Okay.
which you apply in the software so that you can do a direct georeferencing.
Right.
It's reasonably close without ground control.
Right. So in that case, you're talking about correcting, for example, what the INS is reporting as lat long, or XYZ and Omega Kappa Phi, versus where the software says it perhaps might be, and then you can do your lever arm adjustments from that,
Correct.
so that the next time you fly that project, you've got the right information.
Right. And then, what we do on a, fairly periodic basis, we'll fly at a range. We'll just simply do, uh, the process with the direct georeferencing. And if it fits, we have a reasonable confidence level that what we're doing is we're putting out good data.
Mm-hmm.
It's a comfort level. Clearly, if you're putting out bad data, the customer hopefully will tell you right away.
Yep.
But what we found sometimes is, well, we fly the job, we send it to our customer. It might sit in their queue for a month.
Yep. All the
And
while
then
you're
if there's a
flying.
yeah, and then they find a problem. Well, they find a problem after the leaves came out or after the
Mm-hmm.
ground conditions changed, and you can't do it.
Yeah.
So that's not a good thing. Nobody's happy on that one.
Well, and like I said, then maybe you didn't make adjustments, and who knows how many other projects you've flown in that time that might cause the same issue. So the
Yeah.
fact,
But one other,
go ahead.
yeah, one other thing, to talk about that is, we had to become somewhat of an expert on this because in the earlier days, we'd get a complaint, hey, this data's not matching, and for us at the time, well, it was just a black box. We're just giving you the data that came out of the black box, and
Mm-hmm.
we didn't have problem solving capabilities. But as we learn over time, well, maybe somebody used a different geoid.
Oh yeah. Why is my
Maybe,
data off 28 feet?
yeah, why is my data off? Well, there's so many different factors involved
Uh-huh.
on this, and everything has to be exactly right with the project or problem, or it fails. So, and we've had that, where, the client, had a surveyor and the surveyor used, the wrong geoid, and now nothing matches. And now you get into the finger pointing, and so we had to get the software, your software is some that we use to understand, is our data truly good or is there a problem?
Yeah, and to bring up the geoid one's easy because especially in the drone world, that one comes up a lot when someone's processing data and they're like, well, how come my data is off 28 feet? And then in the, when I look at compare it to control or whatever, what, and the first thing you say, well, is it consistent? Is it consistent? Is it 28 feet here, 28.01 here, 28.02 here, on down the line? If it's consistent, then it's a geoid problem probably, and all you have to do is make that adjustment. And I would assume it's the same even when you're doing your bore sight and you see that shift is consistent. Consistent's a good thing,
Right.
It's when
Right.
it's all over the place that you
Exactly.
got other problems.
Yeah.
Yeah.
Yeah. That's right. That's right.
So, fortunately, we do have, like you said, we do now have the software at our hands that where we can figure this stuff out. Because, like you said, in the beginning, it might have been a black box, and it may have come down to a discussion of whether or not, the surveyor was confident in his work, and you were confident in yours, and like you say, finger pointing everywhere. And now, I think before it ever leaves the door, we can have a pretty good idea of everything's consistent, everything's right. We can move forward with it. So, your thoughts on that?
Right. Right. Yeah. So, the reality of where we're at now is, we're confident in what we're putting out as good data. So the first step is just simply make sure we're all on apples and apples and oranges, with our datum, geoid, all these other, factors that enter into it.
Mm-hmm. So another thing you've got going on, and you mentioned that, is now you've got LiDAR sensors and imaging sensors capturing data, maybe at the same time, maybe not, who knows, but you've got two different systems out there collecting information, which have their own calibrations. I would assume that a LiDAR
Correct.
calibration is different
Correct.
than,
Correct.
which creates challenges unto itself. But we can probably agree that LiDAR data of the ground is pretty darn good, especially as we talk about,
Yeah.
with vegetation and other things like that. So at least it's almost like you've got a check with you, because if the LiDAR data is of quality, and your photogrammetric solution matches that, you're probably right on.
Yeah, you have a, you know, everything is consistent and it matches, within itself.
Mhm.
Then, if there's any issues, it's simply somewhere even in the control points.
Mhm.
Again, maybe slightly different datum, slightly different geoid,
Yeah.
that can cause some problems on that. But that being said, from time to time, there is the system doesn't work correctly. We get our data in, and it's just not working. We can't find it out, and we simply have to go out and redo it.
Yeah.
It's perfect.
Yeah. Well, I mean, that certainly happens sometimes. So, I mean, is there, when you're collecting out in this validation field, is there a specific way you want to collect data to ensure that you're going to get a good result, or is it's really more related to the quality of control and the spread out of control within that field?
The only thing that we do that would fit into what you're saying is we make sure we have opposing flight lines. So in other words, each flight line that's adjacent is flown in a different direction.
Mm-hmm.
So in other words, they're not all flown in the same
Right.
direction.
Right. Okay. And then that would make sense because then you're looking at the camera parameters from different directions,
Right.
as you go down it. So,
Taking out any bias somewhere along the way.
yep, yep.
More
Okay.
important with the LiDAR than it is for the cameras.
Okay. Interesting. Yeah. And then, so the calibration itself, performing the or validation, we'll call it, itself. I'll do a little bit of that in the demo, towards the end, and show you how you would do that in correlated 3D. I know, I think you had mentioned me in the past that at least at this point in time, you're using correlated 3D more for that than actual processing of data.
Correct. And the reason for that is we're not advertising ourselves as a mapper, somebody who's going out and doing, large orthophoto jobs.
Mhm.
We have the tools to do that. We don't have the capacity to do
Right.
that, nor do we want to do that. That's not our niche.
Mm-hmm. Yeah, and I guess to my comment to that is that that's one thing that people may not understand is that, the software that we have, Correlated 3D, does that type of work as well. It does AT, and it does quick validation of data. So you may just say when you hit the
Right.
ground, hey, I want to make sure I got complete coverage here. I can run a script and I can see that I got complete coverage. I'm not in the mapping business. That's what my customers do, and they may do it with different software. They may do it with stereo setups and things like that.
That's exactly right.
Which, I mean, that's still, a very viable way to do mapping. And if you're going to do work that involves, say, like curb and gutter, that's the way to do it. Image based processing is probably not going to get you that result. LiDAR will, especially in low altitude and mobile capacity, but not necessarily from high altitude. Um, and I guess to that, you know, you guys are aerial photographers. You're data collectors, not necessarily data processors. So
Correct.
everybody has their own place in the world, just like you're probably not a bunch of surveyors. So, uh,
Right. Right.
you know, so that's
Right.
that's the nice thing about our profession is that, although we overlap in a lot of things, and although we have to understand, what the other side is doing, it doesn't mean we need to do it all. We don't have to become experts in all of that. So, um, it allows you to focus.
Well, yeah, that's right. It was several years ago, a little bit before, we got into the digital world. Uh, in the old days, I knew everything about every process in my company.
Mm-hmm.
Then, as our technology started changing and getting to be diverse and more in depth, I realized that I could not keep up
Yeah.
with everything. It was impossible. So now we've become specialists in different areas. Now we have people that, they process the imagery, and others, they process the LiDAR stuff. And I'm doing contract stuff. It's, we all have our little specialties now.
And this is not a new thing, because back in the day there were aerial photographers who just captured the imagery, and the and the film went off to process somewhere else, because they
That's
didn't
correct.
necessarily have that
That's
equipment.
right.
Or, if you go farther back in the days of glass plates, who had the ability to process out glass plates? Not a lot of people.
No, no, you're going way back now, Eric.
All right, I'm just reminiscing on how old I am.
Yeah. Yeah, well, no matter what you're saying, I'm older.
Yes, well, you might have me about a little bit. So the last thing that I wanted to talk about before, I let you go and we go into a little bit of the demo is, the reason, or we talk about monitoring sensor performance over time. So, you know, to the layman, why do we want to do that?
Well, hopefully that the camera systems are stable internally and you don't run into issues there. But if there's a physical jarring of that instrument camera, the geometry will need to be checked. Uh, what we're doing mostly is checking and validating the IMU and GPS.
Okay.
GPS really isn't much of a monitoring thing, but if we're talking about different aircraft systems, they we move a system from aircraft A to aircraft B, it's going to have a different lever arm. Well, we're going to have to check that just to make sure.
Mm-hmm.
But then you have this potential that your IMU moved. I mean, an IMU, they're precise enough that they can be jarred and moved out of place, and it's not visible
Yeah.
to us as human beings. It can only be measured.
Mm-hmm. Well, and that,
And
that goes to, what we were talking about, the quality of these measurement systems. I mean, they're not in they're not in inches, they're not even in millimeters. They're tighter than that. Um,
yeah,
you know,
yeah, most everything's measured in microns,
yeah,
which is a thousandth of a millimeter. Well,
yeah,
a millimeter is just a little teeny tiny little thing. We'll
yeah.
take that, divide it by 1,000, and there you are.
And the IMU is giving you, roll, pitch, and yaw, and other things. So now you got degrees to deal with, and you know,
Yeah, it's
uh,
yeah, very small,
very small.
very small angles. Yeah.
Yep. Very good. So yeah, so again, in our software and in others, you can do that through the AT process and monitor your camera over time. And really, what you're looking for is big changes, but little changes, you can work with, and you can go with a new calibration. Maybe you've created a new calibration, you want to save it and use that.
Right. You can do that with I would call that a new bore sight if it just micro. So what we're doing, our bore sights in the past have been to, within a pixel,
Mm-hmm.
on our imagery. And, once you zoom in, you can see that, hey, these aren't matching by a pixel. And say, oh, okay, well, that's good enough, or, maybe you might want to tweak that a little bit more.
Yeah.
But that's going to be pretty fine.
Yeah. Well, but again, that's what we're talking about. We're talking about trying to produce the highest quality deliverable for the customer that we can. So um, that's definitely the reason that you want to monitor these things over time. And especially, you may be doing something for them over time, where you're monitoring a quarry or anything like that, and you want to make sure that the results they're getting are the same.
Correct, especially if we're doing a project where there's change detection involved
Yeah. Yeah.
on that, and even though on those projects, even though there might be a new datum set coming out, we stick with the same datum set that we started with, just keep everything the same.
Yeah. And yeah, a lot of times they might have their own, they might have their own global, uh, site setup, so they're not actually on, a datum that we would use or something like that. So, um,
Well, yeah, and of course, a lot of state projects. Several states have gone to a county-wide datum as opposed to a state plane coordinate system. So it's taken a while. Some of the softwares have took them a while to start adding that in,
mhm.
their systems. So we had to do it manually, back in the beginning. So now, when you have projects that cross over multiple counties, well, are you going to stick with a county-based system, or are you going to go to state plane? There's lots of factors to be involved on that.
Yeah, and being somebody who operates nationally, you've got to be aware of that everywhere you're at.
Yep, yep,
Yeah.
yep. Yeah, we haven't gotten into, the different datum systems in Africa or, the subcontinent. We're not doing projects there, but there are some of our larger customers that do that.
Hmm.
We're just not there collecting that data.
Hmm. So, just out of curiosity, I mean, outside of CONUS, where do you guys fly?
We hit the populated areas of Canada.
Oh, okay.
We did. We don't go into Mexico. We know too many stories, and we're
I
busy
know too.
enough in the states. We're just not even messing with it.
Yeah. Very good. Very good. Well, um, I'm going to go ahead and get into the demo side of things for folks. But I want to thank you for joining us. We appreciate having you as a client. I appreciate having you as a peer. Although we only get to see each other, every once in a while at conferences and so forth. Always good to, have someone to bounce ideas off of. And I know I call you every once in a while and we talk about what we're doing in the profession. And I wanted to thank you for joining us. Any last words?
You talked about using multiple systems. We last few years we've been doing projects that involve nighttime imagery.
Interesting.
So now we're getting into using a lidar system and kind of using that as control because you don't have the other visible things to add, even to do as a tie point if you are trying to do it photogrammetrically. It almost has to be on a direct georeferencing
Yes.
methodology, and we can use LiDAR more as the control, for that.
So in
So there's
in a situation like that, what dictates the altitude? Is the altitude dictated by the footprint of the camera or by the optimum swath width of the lidar unit?
LiDAR takes precedence.
Okay.
Typically, the LiDAR swath width is more narrow than the swath width of an optical system.
Okay. Okay.
So, and that works out, especially with medium formats. You might have a 30% side lap, with your LiDAR swaths, but that translates into maybe a 60% side lap on the camera systems.
Interesting.
So you have more imagery, and I know you mentioned that the processing the same. It was medium format or large format. To a point, that's correct.
Mm-hmm.
You end up with more imagery, but if you're going to end up with an ortho photo, you're always using the sweet spot,
Yes.
of the center of the imagery
Yeah.
that way. So you end up with a higher quality
Oh,
and less lean over too if you have buildings in there.
sure. Interesting. Night imagery. That's pretty cool.
Yeah, we're the only ones who's doing that, as far as I know.
Well, very good. Yeah, I hope to see some of that data soon. But again, thanks for joining us. And
My pleasure, Eric.
absolutely. Okay. Well, I'll then move on to the demo part. I have Correlated 3D open. And let's just talk about the options you have in the AT process. So here we have our AT module. And if we select that in correlated 3D, it is going to open up our AT tools on the right side. And you can see we've already run some processing steps here. So we have our tie points. You can see those there. I can turn these off and I can show you some of the different items that we have in here. So we have our tie points, we have our links between images, and we have our images. So here they are. Never mind the blue dots. The blue dots are for the reference ortho underneath. But what I wanted to show folks were the different options when doing AT or performing your bundle adjustment. So we have a few here. First off, let's start with none. So if you were to select none, the intent is that you already have an EO file from, say, another software package like Datum or something like that, where you want to use those existing EO information. So you could do that. You could do the same with the sensor calibration. You could say none, which just means you've already got that and you're happy with what you've got. The next option is, well, we'll talk about this as well, bore site calibration. So we'll go ahead and leave that at none. So bore site calibration is when you want to know the values from, for example, you built your own system where you've got a system where you've got an IMU capturing the XYZ along Omega Kappa Phi along with airborne GPS, and say that is not next to or within some distance of your camera, so your photo center. So bore site calibration will calculate that distance from the camera's photo center back to that IMU. You could then plug those values into your trajectory processing software and eliminate those the next time you use it. So that's very rare that somebody would do that. And honestly, that's because when you're using a system with an IMU and airborne GPS, those values are typically known from the manufacturer or from when you put that piece of equipment in the aircraft. You would never need to run a bore site calibration correlated 3D because that's already been done. That's for somebody who's probably building their own system or trying to back calculate or figure out, maybe has anything changed, so they could do that. The next step would be full AT constrained. So full AT constrained means that you want to perform the AT, but the values you have from your IMU and your airborne GPS are good. You don't want to let the software change those. And again, we're talking about high precision IMUs typically in full-size aircraft. In drones, you're not always going to see that. Even if there is an IMU in there, it might not be the highest quality. So now, same thing with sensor calibration. You can constrain the calibration. So for example, if you have a calibration report that came from another software or the manufacturer, then you could say, we're going to constrain to that calibration report. You would have imported that into correlated 3D when you brought the images in. Then you're constraining it, saying, don't, again to the software, don't change these values. When we look at that, we still have options here. So in this case, we have ground control. Let me turn off the ground control. We'll say no ground reference. So now if we go into these options for our bundle adjustment, you can tell the software which parameters you don't want it to adjust. Is that okay? So for example, if you don't want it to adjust the focal length, the X, the Y, any of these values, you just uncheck them and the software will not modify those. It will assume that what it has is good and it will use that information. Also down here on your EO parameters, you can adjust those a little bit, for example. So say, for example, there was probably, this is in meters. So, for example, there might be 2 centimeters uncertainty in your data for your positioning. So, you would change that to 0.2 or 0.02, and you would do that down the list. And then if you knew, for example, you had a little bit of error in, or you wanted to give it a little bit of adjustment in your omega kappa phi, you could do that as well. So if you said, this is 0.1, these are 0.03. So again, as I mentioned, you can turn off the bore sight calibration because you don't need that. Also, you could see that these are checked, so it says it's going to adjust those a little bit. So again, you would use this if you were confident in your IMU and you were confident in your camera calibration. That's telling to do it this way is telling the software, don't adjust those values, just go with them. You could also, again, add ground control points in. So say if you measured ground control points, and you could see it now adds this up here as well. And this is your uncertainty on your ground control points. So you may have a little bit of uncertainty there in your X and Y or your Z, and you could say, I've got, 2 centimeters uncertainty there. And then the pixel radius is your ability to interpret the target at that pixel. So for example, if there's any motion, image motion, blur, anything like that, you could say, you know what, I'm not confident 100% to 1 pixel, so I'm going to say, or to 0 pixels, so I'm going to give it a 2 pixel radius. So it's going to give it a little bit of float there. You can do that as well. So we'll just say okay there. So that's one option. And this would be, again, IMU, RTK, PPK, whatever, airborne GPS solution, a camera that is metric that is not going to change much. You've probably got a calibration file that was provided by the manufacturer. So that's how you would go about that. The next one would be full AT unconstrained. And that is where you're allowing the software to make all of the adjustments. And especially when you have ground control points, you can always say, you have faith in the ground control points. So let's build this from the ground control on up. And that's how you would do that. You would do full AT unconstrained. You would leave the ground control points in that you had measured. And then it would go ahead and do that. Also with the camera, again, if it's a metric camera, if it's, a high-end camera, then you could probably use that. But you can also do it unconstrained, which will then allow the software to adjust, the focal length, little things like that to get you the best solution. In almost every drone project, this is what you want to do because in all reality, drones don't have metric cameras, and typically the IMUs that are in them are not very good if they even have one. So this would be the method that you would use to do that for drone projects, especially because you've got ground control points. Again, trust the ground control, build up from there. Then the last option is RTK PPK assisted. So again, this is primarily more for the drone world, but if you have a system that has RTK and PPK, you don't have an IMU, but you have that. So you've got quality X, Y, and Z values that come in on your EXIF information. So you're telling the software, I'm confident in the position of the images. Don't change those, but I'm not confident in, or I don't have omega kappa phi. So go ahead and change those as needed. So that is your other option. So, again, when looking at how you're processing your data based on what type of camera system you have, like again, Ken has high-end calibrated aerial mapping cameras. And I think I actually have one of his calibrations up here. Let's see if I can find it. It was, yeah, right here. So here's the calibration procedure that they used for one of Ken's project. And again, we talked about a bore sight where he's checking the quality of his camera, and this just happens to be one of those areas. But you can see he's got control points scattered around. He's got checkpoints scattered around. They go ahead and fly it. They process it to the bore site, knowing that the data should be good. So what they're looking for is they're looking for anomalies or differences in there that shouldn't be there. And, obviously that's not the case normally. So that would be something similar to a calibration that they would do. So from that, you would then just go about your processing. I think we create our deliverables, which are the ortho photos and the mosaic. Of course, we can colorize the point clouds if we need to. I think I've got colorized point clouds in here. Yes, so you would go to, let me get out of AT. You would go to point cloud colorization, got one loaded here. So here's a regular LAS, and it'll take a second. So we have that point cloud, and then we also have, we've run the colorization on it. So you'll see that here. Kind of hard to see with the reference image and ortho there, so let's go ahead and turn those off. And there you can see the colorized point cloud. So we've got that done as well. And that was the deliverables in case for this project. So again, I would like to thank Ken for joining us in this webinar. This webinar will be turned into a podcast. And if you like our webinars and or our podcast, please share on social media. Also, if you did have a question during the webinar and we did not get you an answer, we will get that answer to you as soon as possible. Thanks again for joining us.